Hello, welcome to this video where we are going to solve trigonometric equations with more than one trigonometric function. We're going to start out with prior knowledge by looking at a trinomial structure quadratic equation, and we want to go ahead and solve this equation. Remember, the first step in order to solve equations with trinomial structure are to make one side 0 and move all terms over to the other side. So I have x squared plus x minus 2 is equal to 0. And then I'm going to go ahead and factor this into two binomials. X times x gives me the x squared. I have 2, so that would be 1 and 2. And I want my middle term to be positive, so the bigger value needs to be positive. And thus I have my factored binomials. And I'm going to go ahead now and just set each factor equal to 0. I'll go ahead and solve. And we get x is equal to 1. And we get x is equal to negative 2. All right, so just a reminder, for the functions sine and cosine, the domain is all real values. I can plug in any angle from negative infinity to positive infinity, and the range are going to be values from negative 1 to positive 1 inclusive. Here are the steps in order to solve a trigonometric equation containing more than one trigonometric function, and the main type of problems that are going to be prevalent with more than one function are quadratic structures. And we're going to have one function, say sine or cosine, that is squared, and we'll have another function that'll be different in a linear term. So what we're going to do is we're going to first use a Pythagorean identity in order to write the equation in terms of one trigonometric function. And oftentimes students say, well, which trigonometric function am I targeting, or do I want the expression to be in? And it's whatever the linear term is. So whatever the quote-unquote b value is, that's the function that you will choose. And you'll see what I'm talking about here in a second. Step number 2, we're going to go ahead and use a quadratic strategy to solve. Usually these are trinomial structures, so we will be factoring. And then what we'll do is we'll just go ahead and solve each equation by finding the angle measures that correspond to the function values, okay? Here's our first example. They ask us to solve the equation over the interval 0 to 2 pi, inclusive with 0, excluding 2 pi. So right away what you should notice is that we have 2 sine squared of x plus 3 cosine of x minus 3. Well, my quadratic and my linear terms are not the same. So what we're going to go ahead and do is we're going to go ahead and use the Pythagorean identity. Sine squared x is equal to 1 minus cosine squared x. And what we're going to do is we're just going to substitute out the sine squared x, and we're going to plug in 1 minus cosine squared x. Now make sure you're aware of the 2, because we have to go ahead and distribute that 2. And then now after the substitution, you'll notice that my whole term is, my whole equation is in terms of cosine, which again, like I said, is the linear term. Right, so I'm swapping out that sine squared to be 1 minus cosine squared. And again, that puts everything in terms of cosine. So now after I go ahead and distribute, we can factor. So I'll distribute this 2 times the 1 and 2 times the 1 minus cosine squared. So we get 2 minus 2 cosine squared x plus 3 cosine x minus 3 is equal to 0. I will combine like terms. So I have negative 2 cosine squared x plus 3 cosine x. 2 minus 3 gives us a -1, okay? All right, so now I'm going to go ahead and I am going to open up two binomials, and we're going to factor this. So I will have a 2 cosine x, a cosine x, a 1, and a 1. And then now I just need to know, okay, where am I going to place my negatives? Looks like I want a +3. So if I make my first term negative and my last term negative, that will give me a +2 cosine x. And then I'll just make that one positive, which will give me 3 cosine x. Okay? All right, so we went ahead and we factored. Now I'm going to solve by using the zero product property, setting each factor equal to 0, and solving. Okay, so I'll solve the left side first. I'll go ahead and subtract 1 on each side. I'll go ahead and divide by -2 on each side. Which gives us cosine of x is equal to a +1/2. Okay. So we can go to our unit circle again, and we want our cosine values. Where are our cosine values? Equal to +1/2. Remember, cosine is x values, so it's a pi-3 angle, and then cosine is also positive in quadrant 4, so it's going to be 5 pi over 3. So pi-3, 5 pi over 3 is our answer, and I'll just write that over here. X is pi-3, comma 5 pi over 3. Okay, that's part of our answer. Now I'll go ahead and I'll solve over here. I'll add 1 to each side. We get cosine x is equal to +1. Okay, and this is going to occur at angle 0. Not at 2 pi. Remember, we don't include 2 pi. It's going to be 0. So those are our answers. Pi-3, 0, and 5 pi-3. All right, here is a practice problem. Please go ahead, pause the video, and I will show you the solution here in a moment. All right, hopefully you pause the video. Here are the solutions. We have 2 cosine squared x plus sine x minus 1. Well, I'm going to swap out this cosine squared. I can't factor this since my trig functions are different types of functions. So I'm going to change cosine squared to be in terms of sine squared. So 1 minus sine squared x. And after we go ahead and distribute and combine like terms, we get 2 sine squared x minus sine of x minus 1 equals 0. We'll need to factor that and then go ahead and solve. And so once we do this, we get sine of x is equal to -1/2. Well, sine of x is 1/2 at a pi-6 angle, and it is negative in quadrants 3 and 4, so that would be 7 pi over 6 and 11 pi over 6. Sine of x is equal to 1 at pi-halves, so there is our third angle. All right, next I'm going to go ahead and show you how to solve when you have more than one trig function if you have a linear structure. And what we're going to go ahead and do is we're pretty much going to isolate one trigonometric function on each side. Then we'll go ahead and we will divide both sides by one trig function. Doesn't matter which one, but generally you kind of, want to, I mean, you'll see which one you want to do because you want to solve for a value. Number 3, we're going to go ahead and use a quotient identity. So typically we'll get sine over cosine, cosine over sine, and maybe even sometimes 1 over sine, 1 over cosine, which will give us a secant or a cosecant. Okay. Then we'll go ahead and we'll find the angle measure that correspond to the function values, and then go ahead and check for extraneous solutions. Okay, so we'll want to go ahead and plug them in and check. All right, so here is our first example. you'll see that we have cosine of x plus sine of x is equal to 2 sine of x. Well, I want to go ahead and I want to isolate one trig function on each side. So I'm going to go ahead and I'm going to subtract sine of x on each side, so that on my right side I just have cosine of x. On my left side. On my right side, I'm going to go ahead and subtract. So 2 sine of x minus sine of x is just sine of x. Okay. And then now what I'm going to go ahead and do, what do you guys want to solve for? Doesn't matter. Let's go ahead and we're going to divide by, cosine of x. Divide by cosine of x. And it doesn't matter. I mean, you could divide by sine of x and you would get the same solution. So here we have tan x is equal to 1. Okay, so where is tangent of x equal to 1? And that is going to occur at pi fourths, right? Square root of 2 over square root of 2. And then also at 5 pi over fourths. In the third quadrant, tangent is also positive. Okay, and then there is our solution. All right, here is a practice problem. Please go ahead, pause the video, and try this example. All right, hopefully you went ahead and tried this one. If you go ahead right away, I can't subtract anything or move anything. So right away we're going to divide each side, and I'll divide by cosine of x on each side. So we get tan of x is equal to square root of 3. On this one specifically, I wanted to isolate the square root of 3, so that's why I divided by cosine of x. Okay, and we need to know, where is tan of x equal to root 3? Well, square root of 3 is the bigger value. That's going to go with the bigger angle, which is pi over 3. And then again, in quadrant 3, tangent of x is also positive. So we have 4 pi over 3. Okay, all right. All right, closure. How do you know if a trigonometric equation has a linear structure or a quadratic structure? Pause the video, have a conversation with your partner, and answer this question. All right, and the solution: a trigonometric equation has a linear structure if all trig functions are to the first power. A trigonometric equation has a quadratic structure if the highest power of a trig function is 2. And again, remember, trigonometry is where the trig functions. If I have sine theta squared, we write this as sine squared theta, the same thing. All right, hope you enjoyed the video. Hope you learned something. Catch you next time.